Hi, last time we have talked about the circuits that we see here. Now I want to explain something, and this is about the circuit. This is a formula for V out in open loop. In open loop, the amplification of the amplifier is very big. Actually, if we will look at number of real operation amplifiers, so it is around 100,000. Okay, meaning that this circuit mostly if here is a little bigger than this, so we will have VCC out, and if this is a little lower than this voltage, so we have minus VCC or ground, depending what is connection to this Opamp. So this is the circuit that we want to investigate. We've got this formula from the last lesson, so let's now put some value and check it. For example, I will choose that this resistor will be 5K to make it simple, and this resistor will be 1K. So meaning that in this formula the voltage will be minus this number divided by this. So let's say that we will do everything simple. So we will put in a V in 1 volt, and the divide 5K divided by 1K will give, of course, 5. So the actual voltage out, and we have a minus before this number, so the actual number should be minus 5 volts. In the second case, we will take the same numbers, meaning this one will be 5K, R1 will be 1K, and then we will put it in the formula. So V out will be, again, we will put 1 volt, but this one, don't remember, we have to add 1 before the divided of R2 divided by 1K, so we will have 5K divided by 1K, so we will have 6 volts. This is what we should get out of this circuit. So we will have, if we done everything correct, so we will get minus 5 volt, and in the second case we will get 6 volts. So let's go for LT-Spice and do the simulation very quickly. So I will open a new simulation and put the components. So we have here Opamp. I will take something, it doesn't matter actually, but we'll take this one. I don't know which amplifier, but don't forget, because the actual open loop is the number are so bigger, so huge, so we expect same results. Now I will put the resistors. In order to flip it, we need to press Ctrl R, and then we will have it, and we will put it the same way, R2. So if I want to copy something, I press this, and then I have a copy of it. And now we'll connect the wires and do it quick in order to show that everything is as we expect, and if the theory is good, so we are good to go. So okay, this is a little complicated with all the zooming. So now we want a few voltage. I will explain. First will be, of course, the V in, so I will put it here. We didn't actually yet put number to all the resistor, we will do it soon. So this is our V in. I can call this by names. Just a second, again the zooming is a little problematic. So now we are good to go, and now we will put the numbers. So we said that this will be 5K, this will be 1K, so I will put 1K, for this, and now we actually need to connect power in order to make it work. And I will also put label names for the nets, so we will know which net is what. And another name to vin, our source. So in the graph we will see it correct. Now I will put another, I will now need to put power in order to make this amplifier to work. So I will connect the power to the VCC of the amplifier. If it is go like this, it is not short. It is shorted, so this is not good. So I will cut this wire, and I will cut the V out in order to fix it. Now the V out, I can take it from here because you can see it is the same net, it is shorted. I will put here this will be the load. It actually doesn't change anything, but I need to measure the V out, so I will measure it in this point. So again I will give the name V out because it was deleted before. Now I need to connect ground. I will put this power 10 volts. I hope that this amplifier can manage these numbers, because if not it could burn, of course. Now I will flip because I need to connect negative voltage to the Opamp in this part, because otherwise it can't get to the minus voltage that it should. So now it looks okay to me. Remember, we need to get minus 5 volt if we give a 1 volt, and we will adjust it to 1 volt. Hopefully everything is okay. Now I'm running the simulation. Stop time can be 100 milliseconds. It's much more than we need. And now we will look at Vin. Of course it doesn't change because this is the input. And now I'm checking the V out. Should be in our case, this is the case, minus 5 volts. Let's see. And we get minus, of course. Okay, so you can see that it is not okay because we didn't connect this to ground. We need to connect the positive pin of the Opamp to ground. And now we can run it again. So again the Vin is 1 volt, and we expect now to see minus 5, and we see very close to minus 5. The reason is that we have some drop, very little drop. If I will try to add cursor, let's see, how do I add mark data point? Okay, no, not here. Manual limits. Okay, so let's put a limit at 5 volt and bottom minus 5 volt in order to see the line. Minus 5 volts. Okay, need to, okay, we'll put it between, okay, we don't see the line, but okay, if I'm zooming in, try to zoom again, zoom the graph, so you can see that it is very close to minus 5 volt as we expect. So now what I will do is take the second option. So let's do the second option to see is that the voltage will be changed. Instead of -5, it will change to 6 volt in the second connection. So what I need to do is very simple. Cut here, cut here, cut, and I will move this from here. I will drag it to here, and now I'll connect. We are looking at this circuit, of course, the second one. So we have now the connection to ground here, and the V in, we will take it from here below the ground and now connect it and run it again. So I'm doing the simulation again, and now again looking at V in, it is 1 volt, and now V out should be plus 6 volts, and we are good to go, and we got what we expect. Okay, so this was the second lesson for operation amplifier. I will do some more session in order to show what is going if applying AC voltage and not a DC voltage into the op amp, and we will analyze some other circuit. Thank you for now, and bye.